titrating since I was 2. My top titration tip is dilute, dilute, dilute. If you want to reduce the percentage uncertainty, just dilute. I have a unique method for titration which goes back generations. Number 1. Pipette the solution, preferably 25 centimeters cubed, of the substance you want to find the concentration of into a conical flask, and add a few drops of phenolphthalein. It helps to put it on a white tile so you can see more easily when it finally changes colour. Number 2. Put your solution in the burette. Remember to fill it up with a funnel until the meniscus is at 0. Remove all the bubbles because it reduces the percentage uncertainty. Also remove the funnel because you don't want any drips running down the sides and spoiling your result. Number 3. Do a rough speedy one. This is to get an estimate of how much acid or alkali you need to neutralize a solution, and will help you gain concordant results in the future without wasting too much time. Number 4. Repeat until you get concordant results. My titration top tip is pick up a flask, swirl it around, observe the experiment and then put it down. Chemistry swirl. Health and safety, even though it's boring. What you have to do is don't break the glass and cut yourself on it, and don't drink the acid, and wash your hands after the experiment. I'm going to tell you about maths. When you're doing a titration, you end up with 2 or more concordant results. What you need to do is take a mean of these. See this table? These 2, you're taking a mean of. Look, it's conveniently the same number, 20.5. So we take a mean, that's 20.5. Titration calculations are basically one big extrapolation of data extraction. And what helps you to do this is put it into another table, another big table. Here's one I did earlier. As you can see, you've got the acid and the alkali. In reality, you'd write down what it is. Could be sodium hydroxide, could be hydrochloric acid, but here it's just universal acid. Then you write down the centimetre and you convert it to decimeters cubed, because that's what chemists have said we should do. Then use the concentration of the acid to find out the moles of the acid that reacted with the alkali to neutralise the solution. And from that, you can use the same number depending on the ratio. If there was 2 alkalis to 1 acid, then you'd have 2. If there were 2 alkali molecules reacting with 1 acid molecule in the big equation, then you'd have to double the number of alkali moles, because that's the amount of molecules that react with the acid molecules. Then you can use the volume and the moles that you've extrapolated of the alkali to find out the concentration of the alkali, which in this case is 0.82 moles per decimeter cubed, and then you figured it out. You've done maths. Well done. You should be proud of yourself. Pat yourself on the back.